Hi, I'm Gary McCready from McCready HVAC and Refrigeration. So what we're doing today is installing a dual fuel heat pump system. We have our Lennox furnace and our heat pump A coil right here that sits on the top. This is a case coil. Anytime you want to put in a heat pump, you want to match it up with a case coil because it looks way cleaner than trying to install an A coil in the duct system above the furnace itself. So anytime you can, get a case coil because it looks much cleaner and it's a much easier install. We're also installing a filter rack with a 5-inch filter. It's a media filter, and that prevents a lot of particulate bypassing around the filter. Here's the existing return plenum. What we're doing here is removing the entire drop, and we are going to increase the size of it so we have more return air, and we're going to attach the plenum and the boot to the existing. Start again. So what we're doing here is removing the return drop. The entire return drop is coming out. The reason we're doing that is because we want a bigger return here because we have an ECM motor and we have high duct static originally when we first tested the system before we removed it. So with the high duct static, because we had the high duct static with a 1-inch filter, that's why we're putting the 5-inch filter, more airflow, and we're going to increase the size of this return plenum to have more return air and better airflow through the system to reduce that static pressure within the return duct. So one thing you want to do before you start any install when you're changing over a furnace and an AC to a heat pump slash furnace or even heat pump slash electric heat strips is you're going to want to do a load calculation on the home, speak to a local designer and have your heat loss and heat gain calculations done for you before you go on and select the size of the equipment you're using. So our heat pump is mounted on the side of the home here, and if you're going to mount it on the side of the home, make sure that you're going into brick or concrete. You don't want to go into the side of a home if it's siding because you can have a lot of vibration. In that case, you want to put it on a stand that sits away from the home. But because this is concrete, we should be good here. Now, this Rector Seal bracket that we used is good for up to 500 pounds. The other thing we got to do is cut our bolts off to make it have a cleaner look here. This bracket is good for 500 pounds, and the spec in the manual for the distance from the wall is about 4 inches, and we've got about 6 here, so we've got good clearance there. So they got the foam pads underneath here, and they've got a piece on the bottom that allows you to thread the bolt straight into, and all the bolts and stuff come with the kit. So that's why I like these Rector Seal brackets, and it's a clean look. Make sure it's nice and level, and now what we have to do is match out our hole so we can drill our hole and run our piping. We're going to have the electrician come in and run pipe. We're going to mount the disconnect on the wall here and then feed our whip from the disconnect into the electrical here, and that will be our next step. So what we've done here so far is install the furnace and the filter cabinet, and we have fastened in our gas line. What we chose to do here was use some gas tight. Just make sure to look up the code and make sure you're putting it into code. We use some gas tight because our pipeline moving down and the pipeline here with the furnace didn't match up. So the gas tight is a good product when you have this kind of setup. So make sure you put your drip pocket in and also a union as well, because you want to crack the union here to remove it and not the gas tight where possible. So today what we're going to be doing is piping in our case coil. We're going to be cutting our venting back and installing our venting to the furnace. And here's our drain off the furnace. This particular Lennox comes with this kit here. And what you want to do, and it's in the manual, is you want to have a standpipe that comes off the vent that is no more than 2 inches above the outlet here. And we came across, installed it into our drain. What we're also going to do is cut in a neutralizer, a condensate neutralizer right here. That's really important because these high efficiency furnaces, what happens is they produce acidic condensate. So the acidic condensate can actually start to eat away metal drain materials, and anything that is metal like this grill right here. So it's very important to install a condensate neutralizer on a high efficiency heating appliance. So what we're going to do today is we're going to install our return drop here into the furnace. We have our ductwork and our fittings all ready to go, and we're also going to pipe in our A coil going right outside the cavity right there. Inside the heat pump, what we have is a couple of flared connections. We got 3/8 and 3/4. The nuts are provided, they're already there. So you just got to take the nuts off, and you have to flare your piping. what I would suggest is you use a flaring tool with a pipe stop that does a 45-degree angle flare, and it works really, really well. I like to use nylog on my flare seat. Some people like to use POE oil instead. Some people like to use nothing, but make sure your flare is good. It's also recommended you look in the manual and look at the torque specs and use a torque wrench to torque your nut. So this is 3/4 inch pipe, and it's really hard to manipulate in one fluid run from the outdoor unit to the coil, right? You can end up kinking the pipe if you're not careful. So if you have to do any braze joints, what I would suggest is you do one joint instead of a coupling. You can use a swage tool or a tubing expander. And the other thing you need to do is hook up your nitrogen tank and purge nitrogen as you're brazing. If you don't purge nitrogen as you braze, the inside of the pipe will accumulate the carbon that you're seeing here and can get clogged in the TX valve and any sort of valves and capillary tubes that are in the system. So you always have to nitrogen braze because it will prevent the buildup of carbon inside the pipe. The other thing I suggest you do with the 3/4 is use a tubing bender. Instead of 90s, you can use a tubing bender and you can get nice bends and try to get them nice and round instead of trying to do it by hand. You do it by hand, you're gonna kink it. Most likely you're gonna put kinks in the piping. So I would suggest you use a tubing bender, a good one, and bend your tubing rather than try to use 90s or try to do it by hand. I like to pressure test between 400 and 500 PSI. If your pressure test is not holding, you're gonna have to go soap your joints. If your pressure test holds for an hour or so, then you should be good. You shouldn't have to leak soap your joints at that point. But if you see a drop in pressure as you're pressure testing, pull out your liquid, soap, and leak test all your joints. So after the pressure test is done and your pressure test has held, you're gonna wanna set up your vacuum pump. What I do is I don't use gauges. I go from the system straight to the pump with a large diameter hose, and I use valving. So we can use a valve there and a ball valve here. That way we can isolate the system afterwards when we open up the valves, so the refrigerant is not leaving the system. It's staying isolated with these ball valves, and then we take our valves off afterwards. You want to get down to at least 500 microns. We're down at 34.2. And the other thing that you want to do is make sure that your evacuation holds. So because we have a ball valve right here, we can turn this off from the pump. So now we're isolated from the pump. The pump is isolated from the system, from the valve, and we can watch our micron gauge to see if it rises. You want to see it hold for a few minutes. If it holds for 5-10 minutes on a small system like this, then your vacuum is good, and it's a good way to indicate if you have any leaks as well. So before you start your heat pump, what I suggest you do is set up your fan CFM, which is in this cabinet on the little jumpers. It's in the Lennox manual. And once you set up your fan for the application you're using, you need to check your external static pressure. This is the total external static pressure of the machine. Now this particular Lennox is asking for a maximum of 0.8 inches water column. So we're bang on our maximum. We don't want to go any higher than that. And the way we do this is with a couple of static pressure tips. One in the return. This is the return cabinet down here. And I was able to get it through the other static pressure tip through the screw hole in the bottom of the case coil. We just got to put a screw back in there when we're done. And the static pressure tips basically look like this. They are rounded on the tip and have holes in the side so they catch the ballooning of the effect. They are rounded on the tip and they have holes in the side so they catch the ballooning effect of the duct system external to the cabinet. So very important, because if we go higher with our external static pressure, we can cause damage to our ECM motor, and we may not be able to perform well when we're in heat pump mode, cooling mode, etc. Now for the control wiring, this is a 2-stage furnace. So we have 7 wires from the thermostat down here, and those include our common, the fan, which is G, Y, which is cooling, and we have the W1 and W2, and then we have our O wire right here. So here's the control wiring down at the furnace, and this is a 2-stage Lennox furnace, 2-stage heat. Okay, so you can get away with 6 wires, but we have 7 here. Fortunately, there was enough wires to run this. If there's not, you might have to run some extra wires on your job. So we have single stage heating, 2-stage heating, so W1, W2, our common, our R, G, our cooling, and then we have our wire for heat pump. This is the O wire. So we have 7 wires in total. You can get away with 6 with this furnace because there's a jumper here that allows the second stage of heating to come on a time delay, 5 or 10 minutes. So you can get away with 6 wires, but we have 7. So going out to the outdoor unit, the heat pump, is this wire right here. And there's 4 wires going out to the heat pump. And those 4 wires are common, R, Y, and O. Those go out to the heat pump in this particular application. What I recommend you do with extra wires is wrap them. Don't cut them off, just wrap them. Just in case you ever have a conductor that fails or gets pinched, you have extra conductors here on your wire rather than cutting them off. Just wrap them around and keep them there for future use if need be. Here's our wiring configuration outside. We have our Y attached to Y downstairs. Here's our B attached to the O downstairs at the furnace. Our R and our C. Pretty self-explanatory on this one. So this is what your control wiring setup will look like outside. One thing of importance is we need to make sure that the disconnect is on for at least 8 hours or so before we start the machine up. So what you can do is just make sure none of the control wires are connected up. Turn the main disconnect on. Make sure we have our proper power at the inlet here and the board powers up. This way our crankcase heater will be on and will avoid any potential issues with liquid in the compressor when we go to start the machine up. So if we're looking at the sub base of the ecobee thermostat, here is what your wire configuration should look like. We're wired to G, C, Y1, OB, RC, W1, and W2. When you first turn on your thermostat, it will recognize the connections that you've inputted, and it will bring you through the heat pump setup. So you're gonna have to get the manual out and look through the heat pump setup to see how it's configured. I'll show you some of them right now. So if we go into the menu and settings here, and we scroll to settings here, we can look at the install settings for the equipment, and we are heat pump 2-stage with auxiliary furnace. So that's really important. Here are the thresholds right here. ecobee gives you some recommendations as you're setting it up, what you should set them to. And a lot of these are default. Some of them have been changed. But again, make sure you read the manual and go over this. So we have disabled the compressor at minus 9.4 degrees Celsius. So basically the heat pump won't run below that temperature. It'll be all furnace downstairs. Our auxiliary savings optimization is set at 1.6. And basically what this does is it keeps the indoor temperature within 1.6 degrees of the set point. But again, with the ecobee, it's best that you read the instructions, go through them one by one. But as I said, once it senses the wire configuration for heat pump and 2-stage furnace, what it will do is it'll give you the setup parameters one by one for those. Just look in the manual and set them up for what the manual says it should be for the specific application.